Howdy everybody, Steve here, KM9G. Today we're going to take a look at an upgraded power station from All Powers. A while back I reviewed the SP300, now we have the SP300 Plus. And there's some pretty cool changes about this that I wanted to share with you. And I've got a new solar panel to play with, and I love me some solar panels. This is the SP027, and it is a 100-watt solar panel, and it's foldable, so you can pack it up and take it with you. And there's plenty of room in this bag for the accessories that come with the power station, like a power cord for plugging it into the wall. But we're talking about solar. We're not plugging nothing into the wall. All right, fine. I'll plug it into the wall later. I know how you guys want to see everything. Let's get to it. All right, so what are those differences I was talking about? First off, it has a faster charging speed, and it is both via AC and solar. It will charge faster. Some of these ports up here in the front are changed. We now have one AC port, two USB-A ports, one USB-C port, and then you have your on-off buttons here. On the side, you have DC power out in the form of a cigarette lighter socket, and this will power up your QRP radios, which is nice because this is a nice small battery pack. So imagine taking this thing camping with you for the weekend and powering like your G90 radio or your ICOM 705 or any of your other 10 watt, 20 watt, 5 watt QRP radios, and also recharging your cell phones. And there's a nice little light bar on the back to light up your tent or your overlanding rig or whatever it is you happen to be camping in. And you can even plug in the oddball, weirdo AC stuff that none of us hams like to play with. So that covers the feature changes. Let's get this thing plugged in. Inside of the solar panel bag, we've got some really interesting stuff here. We have the MC4 cable, and this plugs into a DC barrel jack. We have MC4 to XT60, which is what the power station takes. We've got our MC4 cables, and then for that barrel jack, there are a couple of adapters. I would check these guys here out to make sure that they work with the radio or the device or whatever, put out the right voltage, and that voltage is controlled depending on the different amounts of sunlight. This is probably good for charging batteries, but I would be worried about plugging this directly into a laptop or into, this one looks like a Yaesu handheld connector. Because if you do, you're probably shoving 20 volts into a 12 volt device, and nobody's happy with that. We have our manual here. There we go, there's the English stuff. And here are the important specs on this. Open circuit voltage 22.4. So if this thing was plugged in, you'd be shoving 22.4 maximum voltage at your device. Short circuit 6 amps. Maximum power voltage 18 volts. Maximum power current 5.4 amps. So not bad at all. For this power station, we're going to need the MC4 connectors from the solar panel, and we're going to need the MC4 to XT60 cable. So I'm going to zip this up. And then since this is an All Powers solar panel and an All Powers cable and an All Powers power station, I am confident that the XT60 is wired properly to the MC4s for positive and negative. But you have to be careful. You can see that these two connectors here are going to be able to plug into each other. So always check your polarity on these things. But with all Powers gear, there shouldn't be any issues. Let's go plug it in. Step one for working with one of these foldable solar panels is to figure out which way, this Velcro is tight. Figure out which way the legs fold out. These fold out that way, so the panel will lean backwards. And then to open up the flap, and I put it up in this kind of attitude so that when I open it up, that leg lands on the ground. And then I can mess with the other leg, and we're all set from the right side. It's not so bad on a 2-panel setup like this, but I have some of these that are 4 or 5 panels and weigh 50 pounds. So a little bit of planning ahead goes a long way. Nice click sound. Once it gets some power from the sun, it starts to light up. It has a very specific viewing angle. You're probably not gonna be able to see it on camera, but it shows me 67 watts in from the solar panel, 66 watts in. The battery is 67% charged, and it's gonna take 1 hour and 21 minutes to fully charge this battery up. On top of the battery, there is a nice carrying handle, and this thing weighs less than 5 pounds, so it'll be really easy to carry around. And it has a little bit of a piece of rubber there, so that handle's not going to fly open. Another cool thing about this design is that it is completely square. Well, I mean, rectangular, cubically rectangular for you pedantic people out there. But this means that you can shove it in the back corner of something, and you can put stuff on top of it, because some batteries have a big round profile handle on top, which makes it hard to stack things. Look at this wireless charging thing. Let's try that out while we're waiting. So there is DC on, so USB, Type-C, DC. If I take my phone and I sit it on top, it should start charging. And there it went, 83% battery power and it is receiving more power from the battery from the solar panels. I saw that Bluetooth thing just like you did, so I need to long press this DC button with the Bluetooth icon on it. And you hear that beep, and there is a Bluetooth icon in the upper corner. So we've got to go figure out what Bluetooth looks like. So if they did this right, then it uses the existing All Powers app that I've used with all of my other batteries. So I'm going to try that first. Bluetooth is on. Let's set up screen recording. There is my All Powers app loading up. Bluetooth device. Step 1, turn on the phone's Bluetooth function. We already checked that. Step 2, after a short press on the Bluetooth button to turn on the screen, then longer press again to turn on Bluetooth mode. That's on the battery pack like I just showed you. We hit next step and we found it. AP S300 version 3. Okay, so looking at the screen, it agrees with what we saw. This is a lot easier to read in the direct sunlight because it's my cell phone. You guys have seen cell phones in direct sunlight. 68% state of charge. Remaining time on the battery with the current load, which is nothing, 0 output, is 81 days of standby, but it's probably almost infinite standby. And like we saw on the front of the battery pack, it is receiving 63 watts of sunlight out of the 100-watt panel, which is pretty good. I'm not in 100% direct sunlight. Maybe I could move the panel a bit. Let me do that. Go that way. "81 watts of solar. Excellent. It is set for 60 hertz on the output of the AC port, but you can change that to 50 if you just tap the area where it is. You can tell at a glance what's going on with your battery pack. I like having this extra information, but I have no idea why I like having this extra information. Now that we have this thing indoors, I can show you this beautiful display on this thing a little bit better. I'm going to take the AC plug here and give it some AC power. Let's look at the screen when we plug it in. It takes it a few seconds to realize that it's gotten plugged in, and then the screen comes to life. The fan comes on and we're getting 266, 198. We got a little bit of inrush there, and we're going to probably hover around 200 watts in, and it's going to take 35 minutes to charge at 200 watts instead of what it was going to take at the 68 watts before, which I think was an hour and a half. So we shaved an hour off of the charging time. But that display looks pretty good. Bluetooth, time remaining on the charging, 199 watts in, USB, Type-C, and DC. Let's check out AC. That adds AC, and then the fan changed its note a little bit. So we've got all of these amazing ports on here and the wireless charging, but that light's on. But this is a ham radio channel, so I know you guys are going to want to know whether it's got RF or no RF interference. This is the Tiny SA. We're going to try something different today. We're going to use the Tiny SA to figure out whether or not this thing has noise. And this is a really cool 3D printed case. I will leave a link for this in the description down below. You've seen this in other videos, I hope. If not, subscribe. What we're going to need to do for this is give it some frequencies, because right now it's set to start at 50 and stop at 50 and center at 50, which is near 0. I'm going to start, let's just do 14 megahertz. And there's some activity there. Let's do stop of 27 megahertz for no apparent reason whatsoever. Don't read anything into that. Okay, so we've got a little bit of a activity there, a little bit of a dip towards the end. Nothing really noticeable, and we are doing AC charging, AC input. Let's turn on the AC inverter and wait for that to kick in. We saw a little bit of, hey, I heard something, and then it went back to where it was before. And this signal right here that it is tracking on as the loudest signal that's jumping around with that marker on it is at 14 to 18 megahertz, just jumping around. But it's minus 45 dB, so it's not really doing a whole heck of a lot there. Let's turn on DC. No change on DC. Let's turn on Bluetooth. I don't expect anything to show up in the 14 to 27 megahertz range, and there isn't anything. All right, Bluetooth off, AC off. And then let's stop charging and see if that changes anything. All right, we heard some stuff. The world has shifted a bit. The noise level has gone way down. We're at minus 80 dBm. But I've got something extra I want to show you. There is an MPPT charge controller from Power Queen directly in the room. This is the antenna. This is the charge controller. Let's take this out of the room and see what we've got. We're still jumping around at minus 77 to minus 80 dBm, and we can't really find a good strong signal in there. Now we are in the other end of the trailer, about 30 feet away from the charge controller, and our noise reference level is minus 95. So that charge controller is putting out some RF, and the farther we get the antenna away from it, the better. But now we know where our noise levels are, and we have one more test that we need to do. Okay, so now we're back in the room with the noise. We're at minus 80, which is still a good noise level. Let's turn this thing on. And we are on, and then let's turn on the AC power, which is where a lot of your noise is going to come from. All right, so now we're at minus 55 on the meter. Let's turn on an AC load, and I have a heater fan here. We're gonna turn it on the fan mode. Minus 51, and we're pulling 14 watts out to run the fan. Let's turn it on to the low heat mode. And we overloaded the battery pack. So let's reset the battery, because I was watching the battery pack to check out the numbers there. Off, on, AC, wait for it to click in. And I have zero expectations of the 300 watt battery pack being able to run a 400 watt heater. So it validly did overprotect current. It validly did an overcurrent protection and shut itself off so that it didn't hurt anything, including the downstream device, which is really good. Let's get back to the noise test. Okay, so here is the noise. We're gonna turn the fan on low. And we are at 14 watts. Minus 50 dB, just like we were before. Let's turn the heat on to really pull some juice out of this battery, which is going to shut down, but we should see a blip on the SA. A little bit, minus 44, and then she shuts down, and minus 80, back to its normal. I didn't really even need to turn it off, I just needed to acknowledge the alert. And we're at minus 45 dB, so the charger does make some noise. Let's see if it can handle the heater on low with it being plugged into the wall. Yeah, there we go. 500 watts, 555 watts, 582, and then we overloaded when we got close to 600 watts. Okay, so how long will this thing last you? This is a 288 watt hour battery, but they don't really specify which one of the different modes, 120 volts AC or 12 volts DC for the cigarette lighter socket or USB-C. They don't specify what they're running that at. So let's convert the 288 watt hour specification into 12 volts and into amp hours, so it's something we can compare with our favorite batteries from our friend Dennis over at Denko or from our friend Kevin over at BioEnno. This thing converts into a 24 amp hour battery equivalent, assuming zero conversion losses from whatever the 288 watt hour spec is derived from. 24 amp hours. So let's plug our Zygo G90 into it, which is a 20 watt radio that draws 8 amps when you transmit. If we were to just straight key down full 20 watts, which would blow up your radio, so don't do it, this battery pack right here would last you 3 hours under that kind of abuse. Don't do it, but keep that in mind if you were trying to do like a sideband activation at a park on the weekend. This thing would last you all weekend and charge your phone and charge your laptop so that you could do your logging and you could do your spotting and you could have your internet hotspot available and you could run your radio. Seems like a good setup to go camping with. Well, I guess since it doesn't run the heater, you probably shouldn't go camping in cold weather, but it is a glorious sunny day here. I'm in New Mexico today, and I am headed north. All Powers makes batteries of all different sizes, big boy 2000 watt amp hour batteries and little tiny battery packs that you can carry with you in your backpack and recharge your laptop and your cell phone with you while you're on the go. And again, power your QRP radios. I will leave a link in the description down below for this battery pack and this solar panel. You never know what you're gonna run into at a campsite. I guess if I had horns like that, I wouldn't care if anybody was looking at me either. I am on a mission to reach 100,000 subscribers this year, and you can help. Right below the video, there is a subscribe button. It's free, it doesn't cost you anything, but it makes me happy if you click it. If y'all could do that, I'd greatly appreciate it. There is a video right over here I think you'll enjoy next. Thanks for being awesome. I'll see you over there.